Hello students, in this video we are going to solve some of the previous year CT questions. Let's see the first question. Two solutions AB, they are separated by a semi-permeable membrane and liquid flows from A to B. Then here osmosis, students, is the movement of the solvent from lower to higher concentration. They say the liquid is flowing from A to B, means A is at a lower concentration as compared to B. Therefore the answer here is first option. The amount of urea they are asking you to calculate in this question. The volume of this solvent is given, Kf is given. So let us first write down Kf for this question. What is given is 18.6 K mole inverse, but this is for 100 gram of the solvent. So students, always convert this to 1000 gram. What is the unit of this cryoscopic constant is kg mole inverse. So you have to convert this from 100 to 1000 gram. For 100 gram it is 18.6. So for 1000 it will be 1.86. So this is the Kf value. Delta Tf is also given, which is 0.186 degrees Celsius. From the two you can calculate the concentration, that is molality of the solution. So delta Tf is equal to Kf into molality. So molality is equal to delta Tf by Kf. Let us substitute this. So it will be 0.186 upon 1.86. So the molality of the solution is 0.1 molal. Now let us substitute the values here. Students, the name of the solute is urea. So 60 gram of urea, when I dissolve it in 1000 gram of the solvent, I get 1 molal solution. So to get 0.1 molal solution in 1000 gram, mass of the solute should be 6 gram. But they are asking for 500 ml. So for 500 this will be 3 gram. So answer here is second option. 1 mole each. So here the concentrations are same. The first what they have given is urea. Next is glucose. And the third is sodium chloride. Now they say that equal osmotic pressure will be produced. Osmotic pressure is a colligative property, means it directly depends upon the number of the solute particles. So let us first calculate the solute particles. For urea it is 1. Glucose it is 1, and for NaCl it is 2. So equal number of ions will exert equal osmotic pressure. So answer is urea and glucose. Let's see the next problem. Let us first write down what all things are given. Mass of the solute is given, which is 0.15 gram. Mass of the solvent is given, that is 15 gram, which is equal to 0.015 kg. Boiled at a temperature higher means this is the boiling point elevation. So delta Tb is 0.216 degrees Celsius, and Kb, that is the ebullioscopic constant of the solvent, is 2.16. Now from delta Tb and Kb you can calculate the concentration. So that is delta Tb is equal to Kb into molality. Molality is equal to delta Tb by Kb. Let us substitute the values. So the molality of the solution is 0.1 molal. Now let us substitute this. Students, molality of any solution is equal to the mass of the solute upon molar mass of the solute multiplied by mass of the solvent in kg. Let us substitute the values. Molality is 0.1, mass of the solute is 0.15 gram upon molar mass of the solute, what you have to calculate, multiplied by the mass of the solvent, that is 0.015 in kg. After solving this, molar mass of the solute will be equal to, that will come to 100. So the molar mass of the solute is 100 gram. So the answer is first option. Students, you can use a direct formula to calculate this. That is molar mass of the solute is equal to Kb multiplied by mass of the solute multiplied by 1000 upon elevation in boiling point multiplied by mass of the solvent. So this will also give you the answer, that is 100. So the answer here is first option. Let's see the next question. Freezing point of, now here the molality or the concentration is given, that is 0.05 of a non-electrolyte, means I value is 1, and they are given this solution as the aqueous solution. So Kf is equal, for water is 1.86. They are asking us to calculate delta Tf. For this is 0 degrees Celsius, and so the Tf value, that is the freezing point of the solution, will be how much? So the simple formula what we have here is delta Tf is equal to Kf into molality. Let us substitute the values. So that is equal to 1.86 into 0.05. So this will give you 0.093. Let us substitute this value of delta Tf in the equation, that is delta TF is equal to, there is a depression in the freezing point of the solvent when a solute is added. Therefore, it is a difference of the freezing point of the pure solvent to that of the solution. So this value you are getting 0.93, that is equal to 0 minus TF. So TF is equal to minus 0.093 degrees Celsius. So the answer here is first option. Let's see the next question. Now here they have given urea and cane sugar as the two solutes. So let us first make the chart, that is this is for urea and this is for sugar. What is given is they are asking you to calculate the amount for urea. So this is W1. The amount of sugar which is given is 10 gram because it is 10% solution. Volume for this is 1 liter and this is 100 ml. So this will be 0.1 liter. Molar mass of urea is 60 gram and that of cane sugar is 342 gram. Now using this, the word what they have used here is they are isotonic to each other. Isotonic means, students, both the solutions exert same osmotic pressure. So if they are exerting the same osmotic pressure, pi 1 it will be equal to pi 2, and therefore by using the formula pi is equal to W by mV. So this formula we will be using. As the osmotic pressure is same, I can use the formula W1 M1 V1 is equal to W2 M2 V2. Let us substitute the values. W1 upon 60 into 1 is equal to 10 upon 342 multiplied by 0.1. By calculating this, W1 value you will get, that is 60 into 1 into 10 upon 342 into 0.1. So by solving this, you get the answer as 17.04 gram per liter. So the answer here is third option. Which of the following is not a colligative property? Elevation in boiling point, lowering of vapor pressure, osmotic pressure, they all are colligative properties. So the answer which is not a colligative property is freezing point. So the answer is fourth option. Maximum depression in freezing point is caused by, maximum depression in freezing point you have to calculate by taking help of number of ions formed. Now here if I see potassium chloride, here N dash value will be 2. For sodium sulfate, that is Na2SO4, it is 3. Magnesium sulfate, MgSO4, it is 2. And for magnesium carbonate, it is N dash is equal to 2. So the answer will be third option. As N dash factor is more for sodium sulfate, answer here is second option. Let's see the next one. 0.08 kg of the M molar mass is given. So let us first write down what all things are given so that we can substitute the values. Here you can use the formula directly to calculate this. The formula is delta TF is equal to Kf multiplied by mass of the solute multiplied by 1000 upon molar mass of the solute multiplied by mass of the solvent. So delta TF is equal to, now here the cryoscopic constant is 1.86, that is given. Mass of the solute is 0.08 kg. So let us convert this to gram. So it will be 80 gram multiplied by 1000 upon mass of the molar mass of the solute is given, that is 62, multiplied by mass of the solvent, that is 400 gram. So if you solve this, you get delta TF is equal to 6K. Now students, you know that delta TF is equal to T standard, that is of the pure solvent, minus that of the solution. So you got the value for delta TF as 6K. Pure water freezes at 0 degree Celsius or 273.15 Kelvin minus TF. So here when you subtract this value from this, so TF for this you will get 267.13 Kelvin. So the answer here is second option. Let's see the next question. Equimolar salt solutions of which of the following will show maximum depression in freezing point? Maximum depression will be shown where you have maximum number of ions. Sodium sulfate is Na2SO4. So N dash value here will be 3. Potassium chloride is KCl, N dash value will be 2. Magnesium sulfate, for this N dash value is 2. And magnesium carbonate, N dash value here is 2. So maximum number of ions they are seen for sodium sulfate. So there you will see maximum depression in freezing point. So the answer here is first option. I hope you have understood all the questions correctly. So please do like this video and share it with your friends. And please subscribe to my channel to get such more videos. Thank you, students.